evening, guys. Are you able to hear me?
Yes, sir.
Okay, we'll get started. We'll have a quick discussion. So, what is the answer for the first one? How does a charge Q oscillating at a certain frequency produce electromagnetic waves? So, sketch a schematic diagram depicting the electric and magnetic fields for an electromagnetic wave propagating along the Z direction. So, when you talk about the electromagnetic wave, right? So, how would you define it? It is a wave where electric field is perpendicular to magnetic field is perpendicular to direction of propagation. Am I right? So when this is going to be this case, then z-axis will be the direction of propagation. If you take the electric field along x direction, magnetic field will be along y direction, and this is how you draw the required diagram. This is how you draw. Okay, electric field is along x direction and magnetic field along y, and the propagation is along z direction. But the first part of the question is, how does the charge Q oscillating at a certain frequency produce electromagnetic waves? So generally what happens is, you talk about a moving charge can produce both electric and magnetic field. So when you put the same charge particle into oscillation, when I say oscillation, you put it into some acceleration, that is the word they expect, okay? Acceleration, it will produce an oscillating electric and magnetic field with the exact frequency as that of the charge, okay? That is how you are able to get an electromagnetic wave, which is having electric field and magnetic field perpendicular to each other along with the direction of propagation. Right? I hope it is clear, right?
Yes, sir.
Okay. So moving on to the next one. Draw the intensity pattern for single slit diffraction and double slit interference and state the difference between the interference and the diffraction patterns. So when you talk about the intensity varying with respect to distance, right? Intensity varying with respect to distance, you will get graphs like this. Okay. So this is how the graph will be there. This is there as a part of textbook also. Right. So this is the graph for what? So this is the graph for diffraction, and this is the graph for interference or double slit interference, whatever you call it. Okay. So what happens in both the cases? In interference pattern, if you see all maxima and minima, they are of the same width. But in diffraction pattern, what happens is the width of the central maxima is twice the width of the other maxima. Okay. That is one of the differences. And the second is, in the case of double slit interference, each maxima will have the same amount of intensity, that is brightness. Whereas in the case of diffraction, the intensity decreases as you move away from the central maximum. So intensity is this height keeps decreasing. Okay, that is what happens. So these are the two differences, guys. Clear?
Yes, sir.
Okay, if there is any doubt, please stop me. Next. So light of wavelength 5000 angstrom falls on a sensitive plate of work function 1.9 electron volt. The energy of the photon, calculate the energy of photon and electron volt. So energy of photon is equal to hc by lambda, right? So what is hc by lambda? H is 6.624 into 10 power minus 34 into c is 3 into 10 power 8. The whole divided by lambda is 5000 into 10 power minus 10 meter, right? So this value, when you calculate, how many joules are you getting? So you will get the value somewhere around 3.97 into 10 power minus 19 joule. How to convert joule to electron volt? Divide it with 1.6 into 10 power minus 19. Then it becomes electron volt. Okay, when you do that, you will get the answer as 2.48 electron volt. Okay. Next is, what is the kinetic energy of the emitted photoelectrons? This is A. What is the kinetic energy of the emitted photoelectrons? Kinetic energy is equal to energy of each photon minus the work function. So energy of each photon is 2.48 minus work function is 1.9. How much is going to be the answer? It will be 0.58 electron volt. Is everyone clear with this? So this is Einstein's photoelectric equation. So it is 0.58 electron volt. Okay. So two monochromatic rays of light are incident normally on the face AB of an isosceles right-angled prism ABC. The refractive indices of the glass prism for the rays 1 and 2 are respectively 1.35 and 1.45. Trace the path of these rays after entering through the prism. So how to solve this, guys? How to solve? So one thing you need to understand is glass prism is given. For glass prism, what is going to be the refractive index? Sorry?
Sin
1 point?
plus delta m by 2.
No, I didn't get you. I'm saying for glass, what is going to be the refractive index?
Sin a plus delta m by 2.
Okay. I'm not able to hear your voice is very low. So first of all, tell me when the rays are incident here, normal to the surface, what is the angle of incidence? Angle of incidence is 0 degrees. Angle of refraction will also be 0 degrees. Right. So what is going to be the angle here? How much is this angle, guys? I am saying it is 45 degrees, but can someone tell me why I took it as 45? Because I know the fact R1 plus R2 is equal to A. Correct? So refractive index of this prism is 1.35. So mu times sine 45 is equal to 1 times sine 90. If I take it something like this, I'm trying to find the critical angle. Okay, I'm trying to find the critical angle. So what is the value of mu, guys? Mu is 1.35 into 1 by root 2. Okay. So 1.35 into 1 by root 2. Is it greater than the critical angle? Wait. So listen. See, what is the sign of angle of incidence, guys? It is sine 45. Accepted. That is going to be 1 by root 2. So what is sine c equal to? What is the formula for sine c? Sine c is 1 by mu. Right. So 1 by mu means 1 by 1.35. So sine I is 1 by root 2. Sine c is 1 by 1.35. 1 by root 2 is 1.414. Right. Tell me which one is greater among these two. Is 1.41, 1 by 1.414 greater than 1.35 or the vice versa? So since sin I is less than sin c, angle of incidence is less than the critical angle. When angle of incidence is less than the critical angle, what will happen to the refracted ray? The refracted ray will come out of the surface. Whereas in the second case, what is going to happen? Sin I in case number 2 Sin I is still 1 by root 2. What is sin C? That is 1 divided by refractive index is 1.45. So sin I, that is 1 by 1.414 is greater than 1 by 1.45. So what is going to happen? Angle of incidence is greater than the critical angle. When the angle of incidence is greater than the critical angle, for the second ray, it will undergo total internal reflection. Is the logic clear or not? So there is a very important problem. This kind of problem might come. Guys, did you understand the logic? Yes or no?
Sir, we're finding the critical angle to find if it will undergo refraction or total internal reflection, right?
Perfect. Perfect. That's what I did. Okay. So whenever these kind of problems are coming, right, when they ask you to complete the ray diagram, especially for prisms, then the logic that you're supposed to use is with the given angle of incidence, you need to find the critical angle. If the angle of incidence is less than the critical angle, then it will undergo refraction. If the angle of incidence is greater than the critical angle, then it will go total internal reflection. Is that clear? So there is the logic. Okay. Moving on to the next question. Explain the following by giving reasons. When a monochromatic light is incident on a surface separating two media, then both reflected and refracted light waves have the same frequency of the incident radiation. Is that right or wrong? The first place, it is true. So they are not asking whether it is true or false. They are saying that the statement is there, give an explanation to it. So when this is right, since they are talking about frequency, what will be the keyword you need to write? Frequency is the
characteristic of the source.
Very good. So this is what happened in the first question, if you remember. The question itself they gave. Q oscillating at a certain frequency produce electromagnetic waves. They produce electromagnetic waves of the same frequency. That is a characteristic of source. That is a charge which is oscillating. So the keyword that you need to write for you to get marks is frequency is a characteristic of source. That's it. When light travels from rarer to denser medium, then the speed decreases. Does this decrease in speed imply reduction in energy carried by the wave? What is the answer? Is its energy going to decrease? Answer is no. Because here, please write it down. Here, when you're trying to talk about the energy, you're trying to talk about the intensity, which is directly related to amplitude. So energy depends on the amplitude, and the speed is decreasing because there is a change in wavelength taking place. So we understood from the previous concept that frequency is same, but wavelength changes as it travels from one medium to another. When wavelength is changing, speed will change, but that doesn't mean the amplitude is going to change. As long as the amplitude is going to be constant, you can say that there is not going to be any decrease or increase in the value of energy. Okay. Next, for question number C, in wave picture of light, you talk about the intensity which is determined by the square of amplitude. Intensity is directly proportional to amplitude square, according to wave theory. Whereas according to photon theory, how can you write intensity as? Basic definition of intensity is, it is the amount of energy per unit area per unit time. So energy is going to be h into nu, that is the energy of each photon, divided by the area into time. So this is how you define energy in terms of photon theory of light. So h nu is the energy of one photon. If there are n number of photons, you write n into h nu divided by area into time. Clear? So I'm expecting, if there is any doubt, I'm expecting you to ask question. Is it clear, guys?
Yes, sir.
Perfect. Shall I move on?
Yes, sir.
This one. White light is incident on a soap film at an angle of incidence sine inverse of 4/5. And the reflected light on examination by a spectroscope shows dark bands. The consecutive dark bands correspond to the wavelength 6100 angstrom and 6000 angstrom. If the refractive index of the soap film is 4/3, calculate its thickness. I'm extremely sorry about this question. This is not a part of the syllabus. I'm extremely sorry. Marks will be awarded. Don't worry about it. Because you don't have the concept of YDSC inside a medium. Okay, marks will be awarded. Seventh one. Draw a plot showing the variation of photoelectric current with collector potential for different frequencies but same intensity of incident radiation. So how is it going to be, guys? So this is the collector potential or anode potential. Both mean the same. So this is for positive value, this for negative value. So you have right. So this current is called as saturation current, and this is the photoelectric current or photocurrent, right? So what is this called as? Stopping potential minus V naught, minus V naught, minus V naught. So if I take this as 1, 2, and 3, nu 3 is greater than nu 2. Is greater than nu 1. Where this nu 3, nu 2, and nu 1. Guys, did you understand this?
Yes, sir.
Yes. So use Einstein's photoelectric equation to explain the observations from this graph. So how is stopping potential related to maximum kinetic energy? Maximum kinetic energy is equal to E into V naught. Accepted? So E into V naught. So if it has the kinetic energy has to be greater, then the stopping potential will be greater. Why is it so? Because if the electrons are coming out with greater kinetic energy, then you need to apply more amount of stopping potential to put them to make them come to rest. But they are expecting us to use Einstein's photoelectric equation here. So I can write h nu minus W naught is equal to E into V naught. So what can you conclude from this, guys? So frequency will decide the stopping potential. Greater is the frequency, greater will be the value of stopping potential. That is why we wrote something like this. Is that clear? C. What change will you observe if the intensity of the incident radiation is changed but the frequency remains the same? What change will you observe in what? In the photoelectric current and collector potential. So the difference will be something like this. So I1, I2, and I3. So I3 is greater than I2 is greater than I1. Okay. So this is the graph. So what are the difference, guys? In the case of the first one, that is for different frequencies but same intensity, what will happen is the stopping potential will be different. But if the frequency is the same and you have different intensities, then the stopping potential will be the same for everything. Okay. Next. Eighth one. What is the de Broglie wavelength of a bullet of mass 0.04 kilogram traveling at a speed of 1 kilometer per second? So lambda is equal to h divided by mb. H is 6.626 into 10 power minus 34 joule second. The whole divided by mass is 0.04 into velocity is 1 kilometer per second. So 1 into 10 power 3 meter per second. So on solving this, I'll tell you what will be the value you will get. So we'll get the value as 1.7 into 10 power minus 35 meter. Okay. So that is for A. Lambda B, you can similarly calculate. Lambda C, you can similarly calculate. So lambda B will come out as 1.1 into 10 power minus 32 meter. And lambda C will come out as 3 into 10 power minus 25 meters. Okay. So ninth one, it is experimentally found that 13.6 electron volt energy is required to separate a hydrogen atom into a proton and an electron. Compute the orbital radius and velocity of the electron in hydrogen atom. So how to solve this? So what is the formula for energy, guys? So what is the formula for energy?
By root of 8 pi epsilon naught mb.
So what is it?
Q square by root of
U
8
square.
pi epsilon. Q
Root
square.
of Q square. That is the charge of the electron square.
Divided by 8 pi epsilon naught.
Correct. So it will be 8 pi epsilon naught r, and you will have a negative sign. But what is the energy of electron? They have given, no? 13.6 electron volt, or 13.6 into 1 electron volt is 1.6 into 10 power minus 19 joule. This will be 2.2 into 10 power minus 18 joule. Okay, 2.2 into 10 power minus 18 joule is going to be the energy. So if you take everything and substitute it here, you will get the value of R. Okay. So you know what is the radius of orbital radius, right? It is 0.53 angstrom. That is what you're going to get. But they're asking you to calculate it indirectly. Similarly, how will you calculate the velocity of the electron? So half mv square is equal to E square divided by, it is going to be twice this energy, right? So E square divided by 4 pi epsilon naught R, because it is going to be half of this value. So they're asking velocity, right? So V square will be equal to 2 E square divided by 4 pi epsilon naught m into R. R you have calculated from the previous problem. Substitute everything here, you will get a particular value, those many meters per second. If you write this mathematical equation itself, you will get marks. Okay, next. Distinguish between nuclear fission and fusion. This is a question repeated from previous test also. So the procedure is calculate delta M. Delta M is mass of these two. That is 2.014102 plus 3.016049 minus mass of this thing, that is 4.002603 plus 1.008665. So once you calculate the mass defect, multiply the mass defect with 931.5 mega electron volt. That will give you the answer, and the answer comes out to be 17.589 mega electron volt. If you made a mistake in the previous test and you had corrected, you would have been able to answer this. Okay. Similarly, 11th question is also draw the circuit diagram of a full wave rectifier using PN junction diode. Explain its working. So PN junction, the full wave rectifier is also a question from the previous test only. So for a full wave rectifier, you will have two diodes, and you will have a center tapped resistor which is connected across the transformer, which is in turn connected to an alternating source. Right. So during the first half cycle, D1 will be forward biased and D2 will be reverse biased, and you will get half wave rectified. During the negative half cycle, D2 will be forward biased and D1 will be reverse biased. So D1 will rectify the first cycle, D2 will rectify the second cycle. This keeps on going, as a result of which you will have this kind of output. Okay. And the last question is, draw a labeled ray diagram showing the formation of the final image by a compound microscope at least distance of distinction. Okay. So how will it be? You will have an objective, you will have an eyepiece. So an object is placed beyond the focus, and the first image that is formed due to the first lens will start acting as the object for the second lens. For you to get the image at the least distance of distinct vision, what should happen? The first image that is formed should be formed between the focal point and the optical center of the eyepiece, as a result of which you will get the final image at the least distance of distinct vision. Okay. So if you try to label the parts, F0 stands for the focal length of the objective, U0 stands for the object distance. Here also F0 stands for the focal length of the objective. B0 stands for the image distance with respect to objective. Capital D represents the least distance of distinct vision. Capital L represents the tube length, or it is the distance between the optical centers of the eyepiece and the objective. Okay. Having said this, the total magnification produced by a compound microscope is 20. So what do you mean by total magnification? So magnification produced due to objective into magnification produced due to eyepiece is 20. The magnification produced by the eyepiece is 5. The microscope is focused on a certain object. The distance between the objective and the eyepiece is found to be 14 centimeter. If the least distance of distinct vision is 20 centimeter, calculate the focal length of the objective and the eyepiece. So if you take this problem, you know the formula for magnification of the lens of the compound microscope, which is minus L divided by F0. So this is the magnification produced due to the objective, and this is the magnification produced due to the eyepiece when the final image is formed at the least distance of distinct vision. Right? This is nothing but M0 into ME. But ME is given as 5. So 5 will be equal to 1 plus D divided by FE. Our job is to calculate the focal length. So 5 will be equal to 1 plus the least distance of distinct vision is 20 divided by FE. So 4 is equal to 20 divided by FE, which implies FE will be equal to 5. So the focal length of the eyepiece is 5 centimeter. Take this and substitute it in this formula. Okay. So when you substitute it in this formula, we know this M0 into ME is also equal to 20. M0 into 5 will be equal to 20. M0 is 4. So the magnification produced due to the objective is 4, but the magnification due to the objective is L by F0. So L by F0 is equal to 4. L is already given as 14 centimeter. 14 divided by 4 will be equal to F0, which will be 3.5. Okay. Is there anyone who is not comfortable with the formula of a compound microscope with whatever I explained it now? Is there anyone who is not clear with what I explained now? No one. So can I assume that this is clear? At least tell an yes or no.
Yes, sir.
Yes, sir.
Okay, that's it. So if no more doubts, we can wind up.
Sir, I have a doubt, sir.
Please tell me.
Sir, in a diffraction experiment, single slit diffraction experiment, why does the intensity for secondary maxima decreases, sir?
Why does it decrease, sir?
Why does the intensity for secondary maxima decreases?
Intensity of secondary maxima decrease compared to central maxima. Is that what you're asking?
Yes, sir.
That is because there is only one opening, no? So if you have to think logically, when you talk about double slit, there is some light going from here, there is some light going from here. Both these lights together are forming a bright spot. Whereas here, what is happening? The light is going like this. Generally, what will happen if you have a wall here, it should actually form a bright spot here. But light is exhibiting the property of getting bent. So when it is getting bent, the light that is coming from one hole is only contributing to the brightness at these points. Whereas in the case of double slit, what is happening? The light coming from two holes is contributing to the brightness at a particular point. That is the reason why the intensity decreases.
Okay.
Okay. Yeah. Anything else?
Sir, I have a doubt. In the first
Yeah.
question, the electromagnetic wave propagation is along the Z direction. So
Yes, ma'am.
can we select any axis as the electric field and magnetic field, or the order does not matter?
No, order does not matter. See, you should not choose electric field along Z-axis alone. Electric field and magnetic field should not be taken along Z-axis, but electric field and magnetic field among themselves can be swapped between X and Y axis.
Okay,
You're
sir.
able to understand what I told?
Yes, sir.
Yes. Anything else? Anything else, guys?
No, sir.
No doubts.
Okay, then we can wind up.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Okay. Fine.